Guys, in this video, I will be giving a short talk about a proof by contradiction. Well, a proof by contradiction is a form of proof that establishes the truth of a proposition by assuming the proposition to be false and thus leads to a contradiction. Now, you may wonder, why do we need to assume our initial statement to be false and eventually we still able to get a desired contradiction in the end? Well, you will see actually how it works in the following example in a short while. But now I will be introducing you some of the logics behind the proof by contradiction. Here are the three laws that are highly related to the proof by contradiction. Firstly, the law of excluded middle. It states that for any proposition, either is true or its negation is true. Secondly, the law of non-contradiction. It states that every proposition and its negation cannot both be true at the same time. For example, Socrates is a man and Socrates is not a man. Is it possible for him to have different gender at the same time? Well, obviously not. Take another example. Today is raining and today is not raining. Is it possible for these two independent events to be happening at the same time in the same location? Well, again, no. Lastly, the principle of explosion. It states that every proposition can be proven from a contradiction. To be precise, the proposition here must have binary true values which are either true or false. Because of these three laws, the validity of proof by contradiction is governed and ensured to be true. Now, after looking at the logics behind the proof by contradiction, for a math student, we know that square root of 2 is an irrational number, and actually we can prove the rationality of a number using a proof by contradiction. But to make this video simple, I will be proving the sum of irrational number and a rational number is irrational instead. First of all, let the irrational number be A and the rational number be B. And assume for the sake of contradiction, A plus B is rational. And we know that minus B is also rational because B is a rational number, and a rational number, when it's multiplied by -1, it still remains as a rational number. Therefore, taking the sum of two of them, we will get A plus B plus minus B, which equals to A. And A, in this case, must be rational because A plus B is rational and minus B is also rational. The addition between two rational numbers must produce a rational number also. Therefore, A must be a rational number. However, this contradicts our initial claim that A is an irrational number. So, in conclusion, sum of irrational number and rational number is therefore irrational. Besides, we can also prove the generalized Biggen-Hall principle using the proof by contradiction. Take an example as follows. Choose 3 pairs of pens from a drawer that containing 2 different colors of pens. Therefore, from the 3 pairs of pens that we have chosen, at least one of them have the same color. Why is it so? Because now we can start to prove it using the proof by contradiction. Assume for the sake of contradiction, every pair of pens that we chosen must have different colors. So set the first pair of pens as A, B, and C respectively. Then we can pair them out. A pair with B, B pair with C, and A pair with C. Let's consider the case A pair with B. Assume A and B is in different color, and B and C is also in different color. Because there are only 2 colors at least in the drawer, so therefore A and C must have the same color. But initially, our assumption is that every pair of them must have different colors. Therefore, it contradicts our result. conclusion, a pair of them must have the same color. After looking at some of the examples of the proof by contradiction in mathematics, now we can look at some of the applications of proof by contradiction in real life. First of all, actually, proof by contradiction is commonly used in also debating or even in court or even in criminal investigation. In debating, when an opponent is speaking out their view of their topic, if you found some flaws which contradicts their initial stand, then you can actually point it out and attack their weaknesses in the argument by stating their contradictory evidence or claim in their argument. Also in court, when some suspects claim that he or she has a alibi. Alibi is actually means somewhere else in Latin, and generally means when there's a crime that's happening, the suspect is not at the crime, is not doing the crime, and is at somewhere else, which means we actually can't say he or she is guilty because of is guilty in the case. Therefore, we actually can find contradictory evidence to show his alibi is actually false, and to make his punishment is actually indeed true, is indeed legal. Now, in conclusion, mathematics is not only about computations, but it's full of logics, and mathematics and logics are mutually inclusive indeed. That's all from me. Thank you.